morning, students. So in the last lecture we have already seen about the what is the mean by Sn2 reaction and what is the mechanism of Sn2 reaction. So always remember that Sn2 reaction only shown by primary alkyl halides, not tertiary alkyl halides. So what about the secondary alkyl halides? I will tell you later. But one thing remember that only primary alkyl halides shows Sn2, that is a bimolecular nucleophilic substitution reaction, and we have already completed its mechanism and its stereochemistry along with its energy profile diagram. Okay, so today we see that is the Sn1 reaction mechanism. So what is the meaning of Sn1 here? So 1 means unimolecular, N means nucleophilic, S means substitution. So that is the meaning here, unimolecular nucleophilic substitution reaction. Okay, and the unimolecular nucleophilic substitution reaction is shown by tertiary alkyl halides. So that's why in the reaction or in the hydrolysis of alkyl halides we consider the tertiary alkyl halides. So again we see some steps of reaction mechanism. In the first step, that is the reaction. So in the reaction there is a hydrolysis of tertiary alkyl halides by base, or you can say by alcoholic NaOH or KOH, not the base, sorry. So there is a alcoholic KOH or NaOH. So that's why there is a unimolecular nucleophilic substitution reaction. Okay, so let us start with our Sn1 reaction mechanism. So in that first one, that is the reaction. So what is the reaction here? So let us see here, the unimolecular nucleophilic substitution reaction is shown by, so there is the first step, so that is nothing but the reaction. So in the reaction there is a hydrolysis of tertiary alkyl halides. So in the reaction there is a hydrolysis of tertiary alkyl halides. So I take here hydrolysis of tert butyl bromide. Okay, so hydrolysis of tert butyl bromide. So from that you will get tert butyl alcohol. But there is some change in this mechanism. So that's why I consider first reaction. So the structure of tert butyl bromide. So this is the structure of tert butyl bromide. That is what are the carbon is tertiary here, and on the tertiary carbon there is a Br group. So that is nothing but the halogen. So the name of compound is nothing but the tert butyl bromide. So basically this is a substrate. It is called the substrate, or it is a tertiary type of alkyl halides. So listen here, the carbon is a tertiary, so that's why it is a tertiary alkyl halides. When it is a reacts with alcoholic KOH or NaOH, you can take here both. You can take NaOH or KOH. So what is the condition of NaOH here? So it is a alcoholic medium. Sorry, it is a aqueous medium. So it is a aqueous medium. So if you use the alcoholic, then there is a elimination reaction. So that's why it is a aqueous medium. So hydrolysis takes place when tertiary butyl bromide is reacts with the aqueous NaOH or KOH. So there is a elimination. There is a substitution reaction takes place. Means what are the Br is replaced by OH, and you will get the tert butyl alcohol. And what is the byproduct here? NaBr. So this is nothing but your product of the reaction. Okay, so tert butyl alcohol, that is the common name of the compound. Okay, but this reaction takes place in which mechanism? So this reaction takes place by Sn1 mechanism. So how it takes place by Sn1 mechanism? So that's why there is a need to see its reaction kinetics, or you can say its rate or its order. So that's why what is the second step? बघा तुम्ही आता माझ्याबरोबर त्याचं सोल्युशन पण लिहायचं आहे. तुम्हाला मी क्वेश्चन देणार आहे. राइट द Sn1 रिएक्शन मेकॅनिझम mechanism or explain Sn1 reaction mechanism. त्यामध्ये तुमची पहिली स्टेप्स असणार आहे that is a reaction मध्ये काय लिहिणार तुम्ही हायड्रोलिसिस ऑफ टर्ड ब्युटाइल ब्रोमाइड. त्यामध्ये काय सेंटेन्स मेन्शन करायचं बघा when टर्ड ब्युटाइल ब्रोमाइड is boiled with aqueous NaOH gives tert butyl alcohol as a product. So that is your sentence. After sentence you write the reaction. So this is the structure of tert butyl bromide plus aqueous NaOH, and here you can write boil or just make the triangle. No doubt. Okay. And you will get here tert butyl alcohol plus NaBr as a byproduct. So that is your step first. So what is the step second here? So in the step second there is a reaction kinetics, or you can say the kinetics of the reaction. So what is your step second? Kinetics of the reaction. So what is the mean by kinetics? So kinetics measures the rate of reaction, it measures the order of reaction, it measures the how the rate of reaction is depend on substrate, or it may be depend on nucleophile. Okay, so that is all things are nothing but the reaction kinetics. So what is your second step here? Reaction kinetics. But in this reaction, what are the rate of reaction? It only depend on the concentration of substrate. So what is the substrate here? Tert butyl bromide. Okay, not on the nucleophile, that is the OH minus. So that's why the rate of reaction is only depend on the concentration of the substrate, that is tert butyl bromide, not on nucleophile, that is the OH minus. So that's why it is the unimolecular. Why it is called the unimolecular? Because the rate of reaction is only depend on the concentration of tert butyl bromide, not on the concentration of nucleophile. Okay, so that's why I write here the rate of reaction, or you can say just rate of reaction is directly proportional to the concentration of tert butyl bromide. So I write here name, no problem here. So I write just name of the substrate here, tert butyl bromide, not on the concentration of OH minus. Okay, so there is a the reaction, the rate of reaction is not depend on the concentration of nucleophile, that is OH minus. The rate of reaction is only depend on the concentration of substrate, that is a tert butyl bromide. Okay, so in the next step, if you just remove the proportionality sign, then take the some constant here. So I take here constant K, that is called the rate constant, and after that K multiplied by tert butyl bromide. So that is the concentration. Okay, so from this you will get the order of reaction. So what is the order of reaction? So the rate of reaction is only depend on the concentration of tert butyl bromide. So that's why it is the first order reaction. So that's why the order of reaction is 1. त्यामुळे रिएक्शन ची ऑर्डर काय येणार आहे 1. why it is 1? बघा Sn2 मध्ये काय झालं होतं, the rate of reaction is depend on both, that is a CS3Br म्हणजे methyl bromide, and there is a OH minus, that is a nucleophile. So that's why in that case the order is the 2 here, 2. But in this case the order is 1. Why? Because the rate of reaction is only depend on the concentration of tert butyl bromide, not on the concentration of nucleophile, that is the OH minus. So that's why there is only one molecule participate in the rate determining step. So that's why it is nothing but the unimolecular nucleophilic substitution reaction, and the order. So from that you can count the order here. So order is 1 because only one molecule, the rate of reaction is depend on only one molecule. So that is nothing but the order of reaction. Okay, so the next step, that is the third one. So actual mechanism. So the mechanism is divided into the 2 steps. In the first step, what are the attack of nucleophile on substrate is not possible in this case directly, because your substrate is bulky here. So that's why in the first step there is a breaking of CBr bond and there is a formation of carbocation, and in the next step the carbocation, on which the carbocation nucleophile may be attacked from front side, or may be attacked from above the plane, or may be attacked from below the plane, or you can say may be attacked from front side or may be attacked from back side. So there are the two possibility of here. There are the two products are formed in this reaction. So that's why there is a need to see the mechanism in this case. So you know the structure of third butyl bromide. So I draw the, so this is the structure of third butyl bromide. But I draw the wedge formula of this third butyl bromide. So this is your tertiary butyl bromide, no doubt. But I draw the, in the mechanism I draw the its wedge formula. So that's why in the mechanism we will see the step number first, or you can say the mechanism there is a step first. बघ आता mechanism मध्ये आपण step first करणार आहे. So in the mechanism there is a step first. So that step first is nothing but the breaking of CBr bond. Breaking of CBr bond. जसं आपण SN2 मध्ये बघितलं होतं, breaking of CBr bond and formation of COH bond. There is a simultaneous breaking. But in this case, there is only breaking of CBr bond in the first step of the mechanism. बघा mechanism ची पहिली स्टेप काय आहे? Breaking of CBr bond. Okay. आणि इथं तुम्ही काय लिहिणार बघा? In the third butyl bromide, so there are the bulky group. Bulky group. आता कोणकोणते bulky group आहे? So Br is also bulky group. And what are the 3CH3? So that is the 3-methyl. They are also bulky group. So that bulky group make the steric crowding or make the steric hindrance with the nucleophile. That is the OH minus. So that's why nucleophile is not directly attack on the third butyl bromide. So nucleophile is not attack. तरी पण रिएक्शन होते मग त्याच्या मागचा रिझन काय असेल की बघा थर्ड ब्युटाइल ब्रोमाइड मध्ये 3 CH3 काय करतात प्लस आयोनाइड दाखवतात, त्यामुळे कार्बन वरची इलेक्ट्रॉन डेन्सिटी वाढते आणि कार्बन आणि Br मधला बॉन्ड हा ब्रेक होतो, पण ब्रेक होताना कसं होतो स्लोली ब्रेक होतो. आणि म्हणून पहिली जी स्टेप असणार आहे सो दॅट इज नथिंग बट द युअर रेट डिटरमाइनिंग स्टेप. ओके, सो लेट अस सी हियर वी विल गो थ्रू एक्चुअली इट्स mechanism. So I draw here its wedge formula, but before that you write here in the third butyl bromide there are 3 CH3 group and 1 Br group. So that groups makes the steric hindrance with the nucleophile, that is the OH minus. So that's why nucleophile is not directly attack on the third butyl bromide, not attack on the tertiary carbon of the third butyl bromide. So that's why there is a step that is nothing but the breaking of CBr bond. Breaking of the CBr bond. So in this case I draw here there is a wedge structure or wedge formula of third butyl bromide. Okay, so I draw here the wedge formula of third butyl bromide. So there is a tertiary butyl bromide, means always there are the 3 CH3. So what are the 3 CH3 is directly bonded with the tertiary carbon, so you will get the third butyl bromide. So this is the 1 CH3. So what about the 2 CH3? So here one thing remember that what are the CH3 and Br, they are in the plane, and what about the 2 CH3? 1 CH3 is below the plane and 1 CH3 is above the plane. Okay, so that thing important here. So I draw the 1 CH3, so that 1 CH3 is below the plane, so that's why I draw here by the dotted line. So that is a CH3. Okay, so see here, so 1 CH3 is below the plane, and what about the another CH3? So that another CH3 is on the above the plane. So that's why I draw here by the thick line. So you know very well what about the wedge formula. So what are the thick line indicate? So that thick line indicate that what are the group or atom they above the plane, and what is the dotted line indicate that what are the group or atom they are below the plane. Okay, so that is the meaning of thick and that is the meaning of thick and dotted line here. Okay, so these are the nothing but the bonds. So in this case what are the nucleophile is not directly attack on this carbon because what are the bulky group? So CH3, so this CH3 and Br is also bulky group. So what are the nucleophile is not directly attack on this carbon. So that's why there is a two-step mechanism. So why the nucleophile is not attacked? So what are the OH minus? So here CS3, here CS3, here CS3, here CS3. So let us see it's a three-dimensional structure. Suppose I take here, what are the Br and hydrogen is on the plane. What about the CS3? So what are the one CS3 is below the plane. What about the another CS3 is above the plane, and this is your actual structure. So this is three-dimensional structure. But what happened here? So all the groups are bulky. So what are the Br along with the 3 CS3, they are bulky group. बघा आता इथे हे तुमचं स्ट्रक्चर आहे सपोज थर्ड ब्यूटाइल ब्रोमाइड. So this is your CS3. So what are the CS3 is above the plane. So what are the blue CS3 is below the plane, and what are the black? So this is the let us consider this is the black. So this is the Br and this is the another CS3. So all the groups are bulky in nature. So that's why what are the nucleophile is not attacked from this side or this side. So that's why the nucleophile attack is not possible in this case. पण तरी पण रिएक्शन तुमची होते. का होते? कारण की all the CS3 group they show the plus I effect, and due to that what are the electron density on this carbon boson increases, and there is a breaking of CBr bond takes place. So due to that breaking of CBr bond takes place, but this requires some time. So that's why it is a slow step, and you know that what are the slow step indicate the rate determining step. But before that there is one transition state here. There is a breaking of CBr bond, so that transition or intermediate step is nothing but the transition state. So first we draw the transition state. So that transition state requires some energy. So the formation of transition state requires some energy. That energy is nothing but the activation energy. Okay, so that is nothing but the activation energy. So we draw here the transition state. So in the transition state there is a breaking of the CBr bond. Okay, so in the transition state there is a breaking of the CBr bond. So I draw here the transition state. So what about the CS3 here? So here CS3, but this Br bond is break here due to the polarity. So delta minus and carbon having delta plus, and also the what are the electron density on carbon is increases due to the bulkiness, due to the 3 CS3 group. So बघा या 3 CS3 ग्रुप मुळे या कार्बनवरची इलेक्ट्रॉन डेन्सिटी पण ऑलरेडी काय होते वाढते. त्यामुळे कार्बन आणि Br मधला जो बॉन्ड आहे त्याची पोलॅरिटी वाढते, आणि पोलॅरिटी वाढल्यामुळे तो बॉन्ड काय होतो इझिली ब्रेक होतो. पण ब्रेक होताना त्याला काहीतरी टाइम लागतो, वेळ लागतो, म्हणून ही स्लो स्टेप आहे. आणि जर स्लो स्टेप असेल सो दॅट स्टेप इज स्लो. सो दॅट्स व्हाय इट इज नथिंग बट द RDS. अशा स्टेपला आपण काय म्हणतो रेट डिटरमाइनिंग स्टेप. आणि स्लो स्टेप मध्ये आपण रिएक्शनचं काय करू शकतो स्पीड किंवा रेट आपण काउंट करू शकतो. सो दिस इज नथिंग बट द ट्रान्झिशन स्टेट फर्स्ट. आय कन्सिडर हियर ट्रान्झिशन स्टेट फर्स्ट. आता याला मी काय म्हणणार आहे TS फर्स्ट म्हणणार आहे. का म्हणणार आहे त्याचं पण तुम्हाला रिझन सांगणार आहे की पहिल्या स्टेप मध्ये काय होतं फॉर्मेशन ऑफ कार्बोकटायन. सो ब्रेकिंग ऑफ CBr बॉन्ड, और यू कॅन से हियर फॉर्मेशन ऑफ कार्बोकटायन. याला तुम्ही अजून काय म्हणू शकता फॉर्मेशन ऑफ C प्लस दॅट इज युअर कार्बोकटायन. ओके, सो इन द नेक्स्ट after the transition state there is a formation of carbocation, and you know that what about the carbocation? So all the CS3 they are in the plane. So that's why write or draw all the CS3 by the normal bond, because there is a formation of carbocation, and carbocation having positive charge on the carbon. So that carbocation all the CS3 they are in one plane. So that's why this carbocation is the planar. So why it is planar? Because this carbocation, the carbon having the hybridization sp2. So that's why this carbocation is a planar in nature. So why it is called the planar? Because hybridization of carbon is a sp2, and you know the carbocation having the hybridization is sp2 always. So that's why this carbocation is planar. And what are the leaving group here? Br minus. So this is a leaving group Lg. So that is nothing but the Br minus, and you will get the carbocation here. But carbocation having hybridization, sp2, and if the hybridization is sp2, then that carbocation is a planar in nature. All the CS3 they are in plane, and that's why in the next step there is a possibility of nucleophile from back side or front side. But one thing remember here, you know the carbocation is tertiary type of carbocation, and tertiary type of carbocation is stable due to the 3 CS3 group. So what is the property of CS3 group? They donate the electron density to the carbocation. So that's why this carbocation is a more stable or stable. You can say the stable due to 3 plus I effect. So why this carbocation is more stable? Because due to the 3 plus I effect. So what is the hybridization of carbocation here? sp2. So hybridization is sp2, then the carbocation is a planar. And if the carbocation is a planar, then it is a more stable due to the plus 3R effect. Okay, and that is nothing but the stable carbocation. So that's why in the mechanism, first step, there is a formation of carbocation or breaking of CBr bond. Okay, so let us see here what is the hybridization of this carbon here, sp3. Okay, and sp3 carbocation, so it is in the form of tetrahedral nature, but after breaking of CBr bond, that hybridization it changes from sp3 to sp2. So sp2, that is nothing but the planar, and that's why it is a more stable. Okay, so this is about the step number first. So in the mechanism, what about the step number second? So there is an attack of nucleophile. So what is the step number second here? Attack of nucleophile. So which nucleophile here? So there is a nucleophile OH minus. So there is a weak nucleophile is also done the reaction, because the carbocation is stable, so that's why nucleophile is easily attack from back or front side. Okay, so there is a how the tertiary sp3 hybridized carbon is converted into the sp2 carbon. Okay, let us next step here, that is the attack of nucleophile. So again I take here the planar structure of carbocation here. So that is the CS3. So this is your planar carbocation. So this is a carbocation. So that is a CS3. Okay. So this is a carbocation. So there is a possibility to attack of nucleophile from back side or front side, and you will get the two product here. So one attack from front side and one attack from the back side. So before that there is a one intermediate step. So that intermediate step is nothing but the transition state. त्याला काय म्हणायचं आपण? ट्रान्झिशन स्टेट. बघा मी ती ट्रान्झिशन स्टेट काढण्यासाठी इथं थोडं याला अरेंज करून लिहिते बघा. So this is the CS3. So this is your CS3. So this is your CS3. So this is a positive charge. Obviously it is a planar one. And what are the nucleophile is attacked from front side or back side. So it may be attacked from front side or it may be attacked from back side. So we consider here two way here. So in the first way it attack from front side. So this is attack. So I take it is a root number A. So what are the nucleophile it may be attacked from front side, and in the next what are the nucleophile is that may be attacked from back side. Okay, so this is a back side. So this I call it is a root number B. Okay, so I consider two root here, root A and root B. So the nucleophile may be attacked from front side or may be attacked from back side. But before that there is a one intermediate state. That intermediate state is nothing but the transition state. So what are the nucleophile is attacked from back or front side. So that what are the OH is directly bonded with the carbon, but that bonding is not perfectly completed, or you can show in this way. Okay, so this is your CS, no doubt. So this is your what are the nucleophile is attacked, or what are the nucleophile form bond with the carbon. Okay, so that's why this is like that. And what about the 3CS3? They again what about the 2CS3? They again form like this structure. So that is your CS3. But आता इथं तुमचा CS3 आला. And what about the another CS3? So again it will on below the plane. Okay. So this is about the next CS3. Okay. So this is the step. So that intermediate step, there is a formation of COH bond. So that intermediate step is nothing but the TS second. So that is the transition state second. So that intermediate state is nothing but the transition state second. And after the transition state second, there are the two possibilities. So this is intermediate step. So that's why I draw here. But what is the main thing here? So what are the nucleophile? It may be attacked from front side or it may be attacked from back side. So B for back side, and this is A, that is nothing but the front side. Suppose the nucleophile is attacked from front side. So I consider here two parts. So what are the nucleophile is attacked from front side, and the next case what are the nucleophile is attacked from back side. Okay, so let us see here carefully. So first, what are the nucleophile is attacked from? So this is the root number A. So the nucleophile is attacked from front side. So I write here front side. So what are the nucleophile is attacked from front side? न्यूक्लियोफाइल ने कुठला अटॅक केला होता फ्रंट साइडने आणि जेव्हा न्यूक्लियोफाइल हा फ्रंट साइडने अटॅक करतो सो यू विल गेट द रिटेन्शन ऑफ कन्फिगरेशन तुम्हाला काय मिळणार आहे कन्फिगरेशन रिटेन्शन मिळणार कसं रिटेन्शन असतं ते आपण इथे ड्रॉ करू मग तुम्हाला ते क्लिअरली समजेल सो दिस इज युअर वेज स्ट्रक्चर बट व्हाट आर युअर OH here and what about the 2CH3 so that 1CH3 is below the plane okay so this 1CH3 is below the plane and what about the another CH3 so that another CH3 is above the plane okay so let us see here it is not it is very easy part so it is not difficult if you listen carefully and try to understand it you will easily understand this Sn1 mechanism oh like that okay so what is the configuration here so the configuration is remains same as the substrate so in the substrate what happen what are the Br is only just replaced by OH so there is no change in the configuration so that's why it is a retention so there is no change in the configuration so that's why it is called the retention of configuration so retention as it is so retention of configuration so you can say it is a as it is so this is nothing but the retention of configuration okay so this is nothing but the retention of configuration but what about the another case here so nucleophile is maybe attacked from back side okay so another case here because there are the two possibility of attack of nucleophile one possibility is from the front side and another possibility is from the back side why this possibility takes place here because the what is the carbocation is a planar in nature or planar structure so that's why it may be attacked from front and it may be attacked from back side okay so I consider this is the root number B baga so this is the back side attack root number B so there is a back side attack and if the nucleophile is attacked from back side the you know very well in the Sn2 reaction when the nucleophile is attacked from back side then there is a inversion of configuration takes place means what are the product is just opposite image of the substrate but what change here what are the position of Br is just replaced by the OH so that is the one thing here so what is our product here so product is just the reflection of substrate that is the main thing here so I draw here structure again so that is your CH3 okay so there is a reflection means what about your OH so OH is on the opposite side okay and what about your 2CH3 they are on the opposite side okay so here this is your CH3 okay and what about the another CH3 this is above the plane and this is below the plane okay so what is the change here so products are this product is just opposite to the substrate बघा हा प्रोडक्ट कसा आला opposite image आली त्याची सबस्ट्रेट फक्त काय चेंज झालं Br ची जागा कोणी घेतली OH मग अशा केस मध्ये याला म्हणायचं इन्व्हर्जन ऑफ कन्फिगरेशन किंवा त्याला वाल्डन इन्व्हर्जन पण म्हणतात सो इन्व्हर्जन ऑफ कन्फिगरेशन okay that thing important here inversion of configuration but you will get the two products but that two products from the two product which product is major and which product is minor so let us see again here so what are the nucleophile it same attack from front side and same attack from the back side so there is a chances to attack nucleophile from front side and back side are equal so that's why you will get the 50% retention of configuration here 50% retention of configuration and 50% inversion of configuration so that thing is important here but why this happen here because what are the nucleophile have equal chances to attack front side as well as the back side so that's why you will get the two products but what is the percentage of that products so both are the equal in percentage that is 1:1 or you can say the 50% retention of configuration form at the same time 50% inversion of configuration is formed and at the time that two are nothing but the enantiomers of each other. बघा हे दोघांचं जर आपण कन्फिगरेशन जर बघितलं तर हे दोघं एकमेकांची कशी आहे अपोजिट इमेज आहे मिरर इमेज आहे. So that is the non-superimposable mirror images of each other. So that's why these two are nothing but the enantiomers. These two are nothing but the enantiomers of each other. So again these two are the enantiomers of each other. बघा हे दोन प्रोडक्ट जे फॉर्म झाले एकमेकांची कशी एक्झॅक्टली नॉन सुपर इम्पोजेबल मिरर इमेज आहे म्हणून त्याला आपण म्हणू शकतो these two the what are the products formed in the Sn1 reaction. That products are nothing but the enantiomers pair of each other, or you can say the enantiomers. What about the another thing here? Let us see here. There is a 50% retention and 50% inversion. So we will go through the optical activity. Suppose I take the dextro product, so D isomer it is in the 50% and I take the L isomer in the 50%. So what is the resultant here? So your plane polarized light is not rotate because there is a 50% retention, 50% inversion, means 50% D isomer, 50% L isomer. So that's why what about your plane polarized light? It does not rotate, and at the same time this mixture is nothing but the racemic mixture. आपण त्याला काय म्हटलं होतं racemic mixture. There is a racemization takes place. असं काय होतं 50% 50% काय रिटेन्शन कन्फिगरेशन आणि 50% काय इन्व्हर्जन कन्फिगरेशन. दोघं काय नॉन सुपरइम्पोजेबल मिरर इमेजेस. पण हा 50% म्हणजे 50% लाईट तुमची जर राईट साइडला रोटेट झाली तर 50% लाईट ही काय होणार आहे प्लेन पोलर लाईट लेफ्ट साइडला रोटेट होणार आहे. मग ऍट द टाइम त्यांचा रिझल्टंट लाईट काय असेल इट इज अ लाईक ॲज अ प्लेन पोलराइज्ड लाईट. म्हणून या दोघांना काय म्हणायचं रॅसिमायझेशन किंवा दॅट नथिंग बट दॅट कन्फिगरेशन इज नथिंग बट द रॅसिमायझेशन अँड द प्रॉडक्ट इज नथिंग बट द रॅसिमिक मिक्सचर. मग या वेळेस काय तयार झालं रॅसिमिक मिक्सचर. प्रोडक्ट मध्ये काय तयार झालं रॅसिमिक मिक्सचर. रॅसिमिक मिक्सचर म्हणजे काय 50% लाईट हा राईट साइडला रोटेट करतो आणि 50% लेफ्ट साइडला. अँगल सेम असणार आहे फक्त डायरेक्शन वेगळी असणार आहे. त्याच्यामुळे रिझल्टिंग जो लाईट असणार तुमचं काय असणार आहे प्लेन पोलराइज्ड. मग अशा केस मध्ये त्याला काय म्हणायचं रॅसिमिक मिक्सचर. सो देयर इज अ फॉर्मेशन ऑफ द racemic mixture. That thing important here because in the Sn1 reaction the attack it should be from back side and front side. So that's why there is equal possibility to form the two products. That is nothing but the 50% retention of configuration and 50% inversion of configuration, and you will get the racemic mixture. Okay. मग तुम्हाला इथे काय काय टर्म मेंशन करायचे बघा. सेकंड स्टेप मध्ये the nucleophile may be attacked from back side or front side. So if the nucleophile is attacked from the front side then you will get the 50% retention of configuration, and if the nucleophile is attacked from back side you will get the 50% inversion of configuration. So both products having the same mixture of inversion and retention of configuration. So that's why it is nothing but the racemic mixture, and these two products are enantiomers of each other. Okay, so that thing important here. And what about the transition state 2? So in the transition state 2 what are the nucleophile is approached towards carbon and there is a partial bond formed between the carbon and OH, that is oxygen, and that state is nothing but the intermediate state, that is nothing but the transition state 2. Okay, so next thing that is this is about the mechanism. The next one that is nothing but the energy profile diagram. Okay, so I hope you should understand this one. So what are the steps in the mechanism? That is the breaking of CDR bond, that is or called the formation of carbocation, and the next step there is a attack of nucleophile or OH minus, and you can say there is a formation of racemic mixture. Okay, so this is nothing but बघा याला काय म्हणायचं carbocation. So this is a tertiary carbocation and it is a more stable. हा काय असतो more stable असतो. त्यामुळे इथं weak nucleophile पण चालतो. nucleophile weak पण चालेल. ठीक आहे. पण Sn2 मध्ये वीक न्यूक्लियोफाइलची गरज तुम्हाला पडत नाही. तिथे स्ट्रॉंगेस्ट न्यूक्लियोफाइल पाहिजे तरच तिथे अटॅक होतो. ओके, सो लेट अस गो थ्रू द लास्ट स्टेप. सो दॅट इज नथिंग बट द एनर्जी प्रोफाइल डायग्राम. ओके, सो एनर्जी प्रोफाइल डायग्राम. So again, what is the meaning of energy profile diagram? It is the graph of potential energy versus reaction coordinate. That is nothing but the energy profile diagram. You know very well what about the energy profile diagram because already we have seen in the two reaction, there is a what about the on y-axis there is a potential energy, and what about on x-axis there is a reaction coordinate. So that is nothing but the energy profile diagram. But in this case there is a two state or two transition state. So that's why there are the two peak or two transition state, two intermediate state in the energy profile diagram. Okay, so let us see here. So what is the energy profile diagram? So I draw here energy profile diagram. Okay, so I draw this. So what is the energy profile diagram? It is the potential energy versus reaction coordinate. Potential energy versus reaction coordinate, that is nothing but the energy profile diagram. Okay, so this is the x-axis, this is the y-axis. On the y-axis there is a PE. PE nothing but the potential energy. Okay, on the x-axis there is a reaction coordinates. There is a reaction coordinate. Okay, so let us see here. So what is the substrate here? Third butyl bromide. So what is your substrate? Third butyl bromide. So that is your reactor. Okay. So what are the third butyl bromide? So let us see here that third butyl bromide. So first there is a breaking of CBr bond, but for the breaking of CBr bond there is need some activation energy, or you can say that it need or it accept or it acquires some energy, and after that the CBr bond is get break. But at that time there is a one peak here. That peak is nothing but the transition state 1. That peak ला काय म्हणायचं? Transition state 1. कारण या transition state 1 ला काय होतं? Breaking of CBr bond होतोय. And after transition state 1 we get the carbocation. So that carbocation is a stable one. So that's why the potential energy goes on decreases. So बघा potential energy काय झाली आता इथं कमी झाली. का कमी झाली? कार्बोकॅटायन स्टेबल असल्यामुळे. आणि इथं बघा हा कार्बोकॅटायन, आणि फक्त जर कार्बोकॅटायन तयार झाला तो स्टेबल होतो, आणि स्टेबल झाल्यानंतर मग न्यूक्लियोफाइल काय करतो? फ्रंट किंवा बॅक साइडने अटॅक करतो, आणि त्याचं कन्वर्जन तुम्हाला कशामध्ये मिळतं? थर्ड ब्युटाइल अल्कोहोल मध्ये. सो दॅट इज युअर प्रोडक्ट्स. सो इन दिस वे यू कॅन plot the potential energy diagram like that. Okay, so that is your potential energy diagram. Hope you should understand. So this is your carbocation, that is your C plus. So I draw here like that. Okay, so C plus, so that is the tertiary carbocation. So that's why I draw in this way. Okay, so what are the carbon is linked with the 3CH3. So that's why I draw here 3 bond with the carbon, and there is a positive charge. Okay, so this is nothing but the carbocation. याला काय म्हणायचं? कार्बोकॅटायन. Carbon having 3 bond with the methyl, and there is a positive charge. So this is your carbocation. Okay, but what is the main thing here? The potential energy difference between substrate. So this is a substrate. So third butyl bromide is called the substrate. Okay. So the potential energy difference between substrate and transition first. सबस्ट्रेट आणि ट्रान्झिशन फर्स्ट यातला जो डिफरन्स आहे याला काय म्हणाले जातं? डेल्टा E1. डेल्टा E1 ऍक्टिव्हेशन एनर्जी फर्स्ट. ठीक आहे, आणि त्यानंतर पोटेन्शियल डिफरन्स बिटवीन कार्बोकॅटायन आणि दिस इज युअर ट्रान्झिशन स्टेट सेकंड. आता बघा सेकंड ट्रान्झिशन स्टेट कुठं फॉर्म झाली? इथं जेव्हा न्यूक्लियोफाइल अटॅक करतो तेव्हा तुमची सेकंड ट्रान्झिशन स्टेट असेल, आणि यामधला जो डिफरन्स आहे बघा, द पोटेन्शियल डिफरन्स बिटवीन ट्रान्झिशन स्टेट सेकंड अँड कार्बोकॅटायन. So that is nothing but the delta E2, that is the activation energy second. So there are the two activation energy because there are the two step mechanism, and this is the nothing but the carbocation. बघा इथं जो लोअर ला जो पीक गेला परत त्याला आपण काय म्हणतोय? कार्बोकॅटायन. And carbocation is a tertiary carbocation, so that's why it is stable. So that's why potential energy goes on decreases. Okay, so in the next step here product. So what is the product here? Third butyl alcohol. So what is the product here? Third, like the T butyl alcohol. So that is your product. But the potential energy difference between product and reactant, that thing is important here. The potential energy difference between product and reactant, that is nothing but the delta H. And what about the value of delta H here? So that delta H value should be always negative. Delta H value काय असणार आहे? Always निगेटिव्ह असणार आहे. दॅट इज द मेन थिंग हियर बिकॉज देयर इज अ एक्सोथर्मिक रिएक्शन व्हेन द न्यूक्लियोफाइल इज attack on the carbocation from back side or front side. So always the reaction is exothermic. So that's why the value of delta is always negative. Okay. So this is nothing but your potential energy diagram. But what is the main thing here? What about the delta E1 here? So it is the activation energy. So it is the energy difference, or you can say the energy difference. Energy difference between substrate and TS1. It is energy difference between substrate and TS1. That is the activation energy. Next thing here, delta E2. So it is the energy difference. It is the energy difference between carbocation and TS second. It is the energy difference between carbocation and TS second. So what about the delta H? It is the enthalpy change, or you can say the energy difference between substrate and product. It should be always negative. कशी असणार आहे? What are the value? It should be negative. So from that you can say that such type of reaction is exothermic. Because what about the delta H value? It should be negative. Okay. So below the diagram you can write here where what is the delta E1? It is the energy difference between substrate and TS1. What is the delta E2? Energy difference between carbocation and TS second. And what about delta H? Energy difference between substrate and product. It should be the value. It should be always negative. So what is the value of delta H? So delta H value it should be always negative. So that's why the reaction is exothermic in nature. Okay. So that thing important here in the potential energy diagram. Okay. So this is about the overall about the mechanism of Sn1 reaction. Okay. So let us one thing remember here, the Sn1 reaction. So Sn1 reaction is always preferred by tertiary alkyl halides. Sn1 reaction is always preferred by tertiary alkyl halides. Sn1 mechanism कोण दाखवतो? tertiary alkyl halides की ज्यामध्ये बल्की ग्रुप आहे. मग बल्की ग्रुप असल्यामुळे न्यूक्लियोफाइलला डायरेक्टली अटॅक करू शकत नाही. तर त्या केस मध्ये आपल्याला कोणतं टर्शियरी अल्किल हलाइडचं जर हायड्रोलिसिस करायचं असेल किंवा टर्शियरी अल्किल हलाइडचं जर रिएक्शन NaOH सोबत करायचं असेल, KOH सोबत करायचं असेल aqueous, तर त्या केस मध्ये तुम्हाला कोणतं मेकॅनिझम प्रिफर करायचं आहे? Sn1. ओके. सो इन द नेक्स्ट लेक्चर टुडे this is about nothing but the Sn1 mechanism. In the next lecture, what is the rate of the Sn1 and Sn2 reaction with primary alkyl halides, secondary alkyl halides and tertiary alkyl halides. Okay. So there is some point important here. So what is the Sn1 reaction? It is a unimolecular nucleophilic reaction. What is the order of reaction? It is a first order reaction. How many steps involved in this reaction? There are the two steps. Step first and step second. So there are the two-step mechanism. That is the important point here. What is the next point here? It is there is no simultaneous breaking of CBr and COH bond, formation of CO. इथं simultaneous breaking होत नाही. मग इथं breaking काय होतं? Breaking of only CBr bond. Breaking of काय होतं? Only CBr bond. Okay. Next मध्ये आपण काय बघू शकतो? There is a non-polar solvent is preferred by this reaction. म्हणजे in this reaction there is a polar solvent. या रिएक्शन मध्ये जर polar solvent जर तुम्ही टाकलं तर ही रिएक्शन अजून फास्ट होते. That is the one point here. आणि Sn2 चा जर बघितलं तिथं रिएक्शन ही नॉन पोलर सॉल्व्हेंट मध्ये पण होते. पण Sn1 रिएक्शन इज ओनली प्रिफर्ड इन द पोलर सॉल्व्हेंट. पण पोलर सॉल्व्हेंट का टाकायचं? पोलर सॉल्व्हेंट टाकल्यामुळे हा सीबीआर बॉन्ड काय होतो? लवकर ब्रेक होतो. आणि लवकर ब्रेक झाला तर तुम्हाला ट्रान्झिशन स्टेट फर्स्ट मिळते आणि कार्बोकॅटायन मिळतो. कार्बोकॅटायन मिळाला तर न्यूक्लियोफाइलला अटॅक करणारा इझी वे, तो फ्रंट साइड किंवा बॅक साइड अटॅक करेल. पण आता बघा इथं न्यूक्लियोफाइल कोणता टाइपचा घेऊ शकता? इथं बघा स्ट्रॉंग न्यूक्लियोफाइल पण चालतो, वीक न्यूक्लियोफाइल पण चालतो. पण Sn2 ची जर केस जर कन्सिडर केली तर तिथं फक्त तुम्हाला स्ट्रॉंगेस्ट न्यूक्लियोफाइल पाहिजे. ठीक आहे. पण या केस मध्ये तसं नाहीये. वीक न्यूक्लियोफाइल इज आल्सो अटॅक ऑन द कार्बोकॅटायन and there is the formation of the alcohols. Okay, and what is the another thing here? There are the two types of configuration form here. One is nothing but the retention and one is nothing but the inversion. मग तुम्हाला रॅसिमिक मिक्सचर कशामध्ये मिळणार आहे? Sn1 मेकॅनिझम मध्ये. Sn2 मध्ये तुम्हाला रॅसिमिक मिक्सचर मिळत नाही, लक्षात ठेवा. ठीक आहे. मग इन दिस mechanism you will get the both retention as well as inversion of configuration. Sn2 मध्ये काय होतं? only inversion of configuration. तिथं 100% inversion होतं आणि इथं काय बघा 50% रिटेन्शन आणि 50% इन्व्हर्जन. काय झालं की आपण बॅक साइड आणि फ्रंट साइडने इक्वल अटॅक होतो, त्यामुळे इथं तुम्हाला रिटेन्शन ऑफ कन्फिगरेशन मिळतं आणि इथं तुम्हाला त्या पेअरला म्हणायचं इनॅन्शियमर्स अँड सच मिक्सचर इज नथिंग बट रॅसिमिक मिक्सचर. ओके, सो टुडे this is about the Sn1 mechanism. I hope you should understand what is nothing but the Sn1 mechanism. So what is your today homework? Explain Sn1 mechanism with energy profile diagram. बघा लास्ट लेक्चरला मी तुम्हाला Sn2 चं होमवर्क दिला होता, त्याच पद्धतीने Sn1 चा होमवर्क तुम्हाला कंप्लीट करायचा आहे. त्यामध्ये बेसिकली 4 पॉइंट यायला पाहिजे. कोणकोणते 4 पॉइंट? पहिले असेल रिएक्शन मध्ये हायड्रोलिसिस ऑफ टर्ब्युटाइल ब्रोमाइड, दुसरा असेल दुसरा असेल रिएक्शन कायनेटिक्स. रिएक्शन कायनेटिक्स मध्ये त्याचे ऑर्डर रेट तुम्हाला लिहायचा असतो. तिसरा आहे मेकॅनिझम. यामध्ये 2 स्टेप मेकॅनिझम आहे. का की न्यूक्लियोफाइलला अटॅक करू शकत नाही डायरेक्ट सबस्ट्रेटवर, कारण की तिथं बल्की ग्रुप आहे, म्हणून 2 स्टेप मेकॅनिझम. पहिल्या स्टेप मध्ये काय लिहायचं? ब्रेकिंग ऑफ सिलियर बॉन्ड, फॉर्मेशन ऑफ कार्बोकटाइल. दुसऱ्या स्टेप मध्ये अटॅक ऑफ न्यूक्लियोफाइल, सो यू विल गेट द रिटेन्शन एज वेल एज इन्व्हर्जन ऑफ कन्फिगरेशन. ठीक आहे, हे तुम्हाला लिहायचं आहे. आणि चौथी जी पॉइंट असेल किंवा स्टेप असेल दॅट इज युअर एनर्जी प्रोफाइल डायग्राम. एनर्जी प्रोफाइल मध्ये काय काय चेंजेस झाले हे तुम्हाला या डायग्राम वरून कळतं. ओके, सो देयर आर द 2 एक्टिवेशन एनर्जी फॉर्म हियर, एक्टिवेशन एनर्जी फर्स्ट and activation energy second. Okay, so today we stop here. In the next lecture we will see some reaction, and that reaction is goes through either Sn1 or Sn2. Okay, so thank you.